lesson about probability and tree diagrams. First, the basics. The probabilities at a particular junction in a tree diagram must always add up to 1, regardless of whether you're expressing probabilities as fractions or as decimals or as percentages. They will always add up to 1 or to 100%. So, for example, if the chance of rain is 0.7, the chance that it will not rain must be 0.3 because they've got to add up to 1. Now, a tree diagram is just a way of organising your thinking about what all the possible outcomes are from a combination of events. So, for example, in a simpler question, you might just be asked to list all the outcomes if you flipped a coin and rolled a dice, which would be a head and a 1, a head and a 2, a head and a 3, and so on. If the question is a little bit more complicated than that, you might need a tree diagram to help you organise what's going on. So here we've got one where today the weather can either be rainy or dry, and tomorrow the weather can either be rainy or dry. So our options are, it could be rainy today and rainy tomorrow, so rain followed by rain. It could be rainy today and dry tomorrow, so rain followed by dry. Dry today, rainy tomorrow, dry followed by rain. Dry today, dry tomorrow. So I've got 4 possible ways in which these options could be combined. It's only after I've laid my tree diagram out to this point that I start putting any numbers on it whatsoever. So now I will go back and say, well, the chance of rain today is 1/3. So today, the chance of being rainy is 1/3. I know that the probabilities from a particular point must add up to 1. So if the chance of it being rainy is 1/3, the chance that it's dry must be 2/3. So that's where these two numbers come from. And in the question, it tells me that the chance of rain tomorrow is 4/7. So tomorrow, the chance of a rainy day is 4/7. Regardless of whether that follows a dry day today or a wet day today. So if it was rainy today, the chance of rain tomorrow is 4/7. If it was dry today, the chance of rain tomorrow is 4/7. And because the probabilities from a particular point must add up to 1, if the chance of rain tomorrow is 4/7, the chance that it's dry tomorrow must be 3/7. Now that I've got these probabilities on, I can work out the combined probability of 2 rainy days and so on. So what I do here is I multiply along the branches. So I do 1/3 times 4/7 to get the probability of rain followed by rain. When you're multiplying fractions, it's top times top, bottom times bottom, so that gives me 4/21. Here I would have 1/3 times 3/7, which I know could cancel to 1/7, but it's easier if you leave all the denominators the same for reasons that are going to become clear down here. Dry followed by rain, 2/3 times 4/7, dry followed by dry, 2/3 times 3/7. Now, to double check that I haven't just made a silly slip with my arithmetic, I always put in a check at this point. This is why it's easiest if I leave all the denominators the same. All of these probabilities should add up to 1. So a quick double check. 4 added to 3 is 7, added to 8 is 15, added to 6 is 21. So I've got 21 21sts, so I haven't made any obvious slips up to this point. If you've got to here, you've really done all the work in the question. All that will be required of you from here onwards is to read answers off of your diagram. So the first part says 2 wet days. So in other words, a rainy day followed by a rainy day. The probability was 4/21. At least 1 wet day. At least 1 wet day means 1 wet day or more than 1 wet day. So I'm looking at these 3 options. Rain followed by dry, dry followed by rain, and rain followed by rain. Now that I've got different paths through the tree diagram which meet my criteria, instead of timesing, now I add the combined results together. So it's 4 21sts, add to 3 21sts, add to 8 21sts, which gives me my answer of 15 over 21. Okay, so now we're going to come on to a slightly more complicated tree diagram. Very typical question. You've got a bag with some chocolates in it. 5 are dark and 3 are milk. So this is what my bag of chocolates looks like. Anne takes 2 chocolates from the bag and eats them. So after she's taken her first chocolate, she doesn't put it back in again, she eats it. Draw the tree diagram. So let's get that done first before we worry about any of these questions. You might want to stop the video here for a few seconds and see if you can sketch out the tree diagram and then check it against mine. So your diagram should have looked like this. The first chocolate that comes out of the bag could be a dark one or a milk one. The probability of getting a dark chocolate is 5 dark chocolates out of 8 chocolates in the bag, so 5/8. The probability of a milk is 3/8. Now, if I took a dark chocolate first, the probabilities for my second chocolate, which could either be dark or milk, depend upon the fact that I've already eaten one of the dark chocolates. So one of these has gone. So I've now only got 4 dark chocolates left in the bag and 3 milk chocolates. So the probability of drawing a second dark chocolate out is now 4 out of 7. And a milk chocolate is 3 out of 7. However, if the first chocolate that I drew was a milk chocolate, the bag now looks like this. This one has gone. So the chance of following a milk chocolate with a dark is going to be 5 out of 7. And the chance of following a milk chocolate with a milk is going to be 2 out of 7. So this is called conditional probability, because the probabilities for the second part of the tree diagram depend upon what happened in the first part of the tree diagram. From here onwards, though, it's exactly the same as the example above. So to combine the probabilities for a dark followed by a dark, we times along the branches of the tree diagram. So that's 5/8 times 4/7. Top times top is 20. Bottom times bottom is 56. Dark followed by milk, 5/8 times 3/7, 15 out of 56. 3/8 times 5/7, 3/8 times 2/7. Put in your double check to make sure you've not made any silly slips. So I've got 20 56ths, add another 15, so that's 35, add another 15, so that's 50, add another 6, I've got 56 56ths. So that's okay, I've not made any obvious errors. Now all I've got to do is go back and answer the questions to get all the marks. So the probability of 2 dark chocolates, a dark followed by a dark, 20 56ths. The probability that one of them is dark and one of them is milk, either way around, so that's either a dark first followed by a milk or a milk first followed by a dark. So the combined probability of those two options is 30 56ths. There's this phrase here again, at least 1 dark chocolate, so that means 1 dark chocolate or more. So that's a dark and a dark, a dark and a milk, or a milk and a dark. If you add up these 3 options, it gives you 50 out of 56.